without changing in 3-digit numbers. Why I am showing this particular slide is because I want you to tell the children, take away 1 from 3 ones. Take away, how many tens? 4 tens from 7 tens. Take away 300s from 400s. Meaning, children you should drive into their head. You can take away a 1 from 1, 10 from 10, 100 from 100. You can't do it any other way. You can only change and do it. You cannot take away a 1 from 100 directly. You have to change it. That is why it is important that you spell these steps. Anyway, with changing, after you do with base 10 blocks, you have to start using abacus. Why I am using abacus after this is because this is semi-abstract. When I say 275, in the place value block, you had 200s which were big enough and 7 tens and 5 ones. The tens was really, it had 10 ones in it. The 100 had 100 ones in it. But here, just by placing the beads in the appropriate place, you have got the number. So abacus should be used only after you use the place value blocks. You use the place value blocks here, okay? Then add appropriate number of beads and ask them to count the beads together. Again, there is a question which is always asked. Should I add ones first or hundreds first? My answer will always be you can add anywhere. As long as you are adding tens to tens, ones to ones, hundreds to hundreds. Only in the standard algorithm, we move from right to left. Actually, you can do addition, subtraction anyway. Left to right, right to left, middle to left to right, any way you can do. That will be the actual strategy. So after you do all this, you have to do the standard algorithm which you all have been doing in your classrooms. Give them, tell them, when you have 85 minus 17, strike the 8, put the 7, change, put that 1 here. All the standard algorithm has to be done only after you go through all these stages which I have told you. For every child, standard algorithm is a nightmare because it doesn't make any sense. Okay, so always, use a place value in a checked boxes. Always use them and support it with manipulative as long as the child requires. You tell him that it is not any magic, or it is not because I am telling you, you have to do it this way. It is just that we are doing a shortcut, or it is the shortened way of doing things. The standard algorithm is just a shortened way, that's all, though it is the most difficult way. Now you start introducing strategies. Before you start introducing strategies, just throw problems to children. You ask them, without using the standard algorithm, using your paper pencil, think of ways in which you can solve these problems. You will be surprised. I have tried this in many schools where I am consulting. The teacher has not taught any strategy, but the child's own understanding, he has brought out strategies. If the child is not able to get any strategy, lead him. Okay, think, give them leading questions like, think if you can just add the tens together and then put it as hundreds. Give them leading questions. The use of manipulatives, what question you are going to ask, varies from child to child. This is one of the first strategies. Suppose I want to add 37 plus 55. You do that by decomposing the numbers. 37 can be written as 30 and 7. and 55 can be written as 50 and 5. Add the tens, add the ones. No? So you have the answer. This is one of the strategies. For subtraction, again splitting the number. 84 minus 22, split 84 into 80 and 4, 22 as 20 and 2. Subtract 2 ones from 4 ones, 2 tens from 8 tens. So you have whatever you have, you know, you can do. Okay? When you are doing this, you have to simultaneously, I know you have raised hands, I know all of you want to ask me something. We'll do it at the end of the PowerPoint. And if I promise you, if any of you want to talk to me, I'll come on a Skype call with you or a WhatsApp call with you. A WhatsApp call with you later. When you are doing this strategy, it is very important that you teach them number bonds. 10 can be written as 3 and 7. 10 can also be written as 2 and 8. No, in other words, you have to give them, there are several ways of writing a number. 2 can be written only as 1 plus 1. But 3 can be written as 1 plus 1 plus 1. Or it can be written as 2 plus 1 or 1 plus 2. 4 can be written in many more ways. You start introducing them to all this just as a form of exercise. No, you don't, hey, come on, tell me, what are the ways to write 4? No need. Just give them as a warm-up exercise. Can you show me 4 in different ways? This is 4. This is 4. This is 4. This is 4. You understand? This is a must before you do other strategies. Just as a 2-minute exercise before you introduce. 1 minute. Oh, sorry. Yeah. The next strategy, I've given the 2-digit and the simultaneous, I've written it and shown you. Again, this is one of the students with whom I worked in my house. Okay. This child, 89 plus 34, which I told you earlier, breaking. The same thing, he could do it on a number line also. See what he has done here. He has jumped 89. After that, he has, in the first 2-digit addition, in the topmost thing, both the numbers were split. 80 plus 9 and 30 plus 4. But when you are doing it on a number line, 89 is not split. He is jumping by tens. He is splitting only the 34. Okay, 30 and 4. He jumps 30 and then 1, 2, 3, 4. Hello, can you hear me? I hope you are able to understand.
Yes, we can hear you. We can hear you.
Okay.
Yes, ma'am.
Then in the next step, you can see, he is writing 9 plus 4, 13, like you write for 2-digit, multiplication. He's not writing the 1 on top. He's writing the 13 of 9 plus 4, 13, 3 in the ones place and 1 in the tens place.
Class ஆரம்பிச்சு போகுது
adding 8 tens and 3 tens, he's having 0 ones and he's having 11 tens, and he's writing in that 11 the first one in the tens place and the one in the hundreds place. This is similar to something which you do in multiplication by 2 digits. No, you write below, one below the other. This is another strategy which you can teach children. Okay. Then he has done the standard algorithm. I hope you are able to see all this and understand. The same thing he has done for a 3-digit number also. 389, again in the first thing he has broken both the numbers as 300 plus 280 plus 9, 200 plus 50 plus 3, hundreds together, tens together, ones together. In 389, in the next one, a number line, he has first jumped hundreds, then jumped tens, and then jumped ones. And the vertical addition is very, very interesting. No, I hope you are able to understand. And then he did the standard algorithm. Why I made him do all this is because this boy's name was Balaji.
Mobile data.
Okay, why I made him do all this was because I wanted him to see whichever way you do, the answer comes to be the same. Okay, the same thing I'm going to show you in few more slides. Look here, you know, 45 plus 17. Look at the way the child has done. Let's start off it 45 minus 17, sorry. 45 minus 17. Okay. Can you see the first one on top? He has thought of it as an 3, the friendly number concept. Your friendly number concept. 17 plus 3, 20. Of the 45, I have added 3. Now he is adding another 20. Again, friendly number concept. The tens are all called friendly numbers. Okay. So to the 20 which he got in the first step, he adds another 20. He gets 40. He has to reach 45. So he realizes that he cannot add a 10. So he adds 5 ones. So what is it that he has added to 17? 28. And for many of you, this may look very complex. But you will find that 30% of the children think of subtraction like this. You will be surprised. I'm telling you this. Next to the compensation method. Okay. 45 minus 20. 45, no, he has to do only 17. But 20 is a friendly number. So he subtracts 20 first. He subtracts 20 first, goes to 25, but he understands he had to do only 17. So he adds back 3. This is another strategy. Then decomposing 10 is another strategy. 45 minus 17, he has decomposed both. Okay? But when he decomposed 40 plus 5, he sees that he cannot take away 7 ones from 5 ones. So he further decomposes it to 30 plus 15 and then takes away 7 1 and 1 10 or 10. So now he very well understands what he is doing is a shortcut. The standard algorithm is a shortcut. I have to tell you, all my friends there watching me in the Zoom, that we are so used to standard algorithm and we have got now used to it. So for many of us, all of this may look very complicated, but actually it is very simple. Okay. So I move on to my next slide. I know it's getting late. Just give me a little. Okay. I told you about the friendly number concept. So when I want to do 27 plus 9, just to reiterate my point which I have told you earlier, move to the nearest 10. Okay, 3, which gives me 30, and then add another 6. Okay, even on a number line, each of the child may do it differently. This picture I picked up somewhere. When I want to add 37 plus 48, look at the first thing. First I add 40. I hope all of you are able to see me, see what I am showing here.
Yes, yes, ma'am. Yes.
And then add another 8. They get the answer. This is one way. The next way is first they add 40, they get 77. They started with 30, ma'am. Here they are starting with 37 and jumping 40, 77. Now moving to the friendly number and then adding again 5 more. Okay. The third way is first move to the friendly number 40, then add 10s, then again add 1s. I hope all of you are able to see me and be with me. I hope you are understanding what I'm saying.
Yes, ma'am.
Okay, the same thing with subtraction. When I want to do 74 minus 27, there are several ways to do it. Here, from 70, friendly number concept, 74 to 70, I take away 4, but I have to take away 27. Okay, till I move on, I hope you understand. So from 27 to come to 44. Okay, he's, sorry, first time I told you wrong. From 27 to come to 74, a friendly number concept, first he moves to 30, 40, and then 4 more. This is what has been shown here in subtraction in a 3-digit also. 512 minus 386. You move from 386 to 512 using the friendly number concept. Move to 390. I have still not reached 500. Okay, add hundreds, then add the remaining. There is another way of doing it, moving the back way, which is what I was telling you earlier. Jump in tens, which the child generally is able to do easily, and then minus the ones. Okay, so there are several ways of doing all these things. All you have to do is you should be aware of all the ways. Okay, sometimes you can decompose only the second number, which I told you earlier. But why I gave this slide is because this is slightly different from what I showed you earlier. Okay, 124 plus 300, okay, gives me 424. See, at this stage also he can move to the friendly number concept. Okay, he could have done, even broken this into further steps. The child is not able to think of bigger steps. Okay.